Pearson correlation with Python between non-destructive and destructive tests applied to concrete beams with recycled aggregates. Introduction. When using concrete elements in construction practice, it is often necessary to verify some properties of the concrete made elements through destructive tests. In most cases, destructive tests are invasive to the elements and complicate the performance in the field. An alternative is the use of non-destructive tests. The objective is to verify the existence of a correlation between destructive and non-destructive tests for beams designed with recycled aggregates and a percentage of blast furnace life. Experimental procedure. Four types of concrete mixes were prepared: control with 10% blast furnace life, recycle, and recycle with 10% blast furnace life. From these mixes, 48 beams were produced that occurred with norm HTMC 78. Non-destructive and destructive tests were conducted on the beams at different ages: 7, 4, 28, and 90 days. The tests include ultrasonic pulse velocity, electrical resistivity, and flexural strength. The methodology for generating correlation maps. The first step, dataset creation. The evidence collection was created and ordered according to the mixing radio. Data preprocessing. It was verified that there were no null values in the dataset. Data description. The statistical analysis of the data to obtain values such as media, quartiles, standard deviation. Application of correlation. The correlation applied was Pearson with the Seaboard library. Comparison of correlation between mixes. Generation of correlation mapped graphs. The next graphs correspond to correlation maps for the concrete mixers. The dataset was separated in the different types of mixers. The first graph is correlation of tests of witness beams. Correlation in witness beams with 10% blast furnace lag corresponds to the second graph. And the third graph corresponds correlation in beams with recycled aggregates. For last, the fourth graph is correlation in beams with recycled aggregates and 10% slag. The results. The best correlation between the characters age, electrical resistivity, ultrasonic pulse velocity, and the target test flexural strength for the mixtures were as follows. Control IR with the value 0.14, indicating a very low correlation. Control with 10% slag, IR with a value of 0.52, indicating a moderate correlation. Recycle IR with a value of 0.49, indicating a low correlation. And the last, recycle with 10% slag, IR with a value of 0.57, indicating a moderate correlation. In general, we can observe it that the electrical resistance it is the best characteristic influence of helping to infer how good the flexure strength will be. The correlation vary depends on the mixture, and the data is mixed across different ages, which may be causing the correlation to be less objective. Conclusion. No-destructive tests may provide an indication of the behavior of beams subjected to flexure strength, with electrical resistivity being the non-destructive tests that show the best correlation. To confirm this, a large database could be used, and the test could be monitored during execution to ensure that the results are accurate. Acknowledgements. The authors would like to acknowledge to the Laboratory of Materials, of Faculty of Civil Engineer, of University Michoacana of San Nicolas de Hidalgo.